Right now, somewhere out in the dark, the light of a galaxy is falling toward us that we will never be able to reach. Not only because it is too far for any rocket, though it is because the space between us and it is stretching faster than light can cross it, so that a beam we sent out tonight, moving at the fastest speed anything is allowed to go, would never arrive. That galaxy is not some rare case at the far edge of things, it is almost all of them. More than 9 in 10 of the galaxies we can see are already beyond any reach we could ever have, sealed away not by distance but by the expansion of the universe itself. We talk about space as the final frontier, the open country we will spread into once our machines are good enough. But the universe is not open. It is closing, and almost everything in it is already on the far side of a wall we cannot cross. So the question tonight is not how far out we can go, it is how little of it was ever ours to reach. Tonight we are going to walk the walls of that prison, one by one, and see how completely they seal us in. By the end of this you will understand why the speed of light is not a speed limit but a cage, why the expansion of space has already put most of the universe permanently out of our reach, and why the small part we can still reach is shrinking every year, until in the far future the sky empties out, and even the proof that the rest was ever there is gone. I am not going to tell you we will find a way out. The honest truth is harder than that, and it is this: we are not explorers standing at the edge of the universe, about to step into it. We are already sealed inside a small and shrinking part of it, and almost everything else has already left. If you like standing in the hard, honest places out here with me, a quick like or subscribe helps these videos find the other people who would too. Now, let us begin. Start with the simplest version of the problem, the one that has nothing to do with anything exotic, just distance. Out beyond the planets, moving away from the sun at about 17 kilometers a second, there is a small craft called Voyager 1, launched in the late 1970s, and it is the most distant object human beings have ever made. After nearly 50 years of flying, it has just crossed a milestone that tells you everything about the scale we are dealing with. It is now about 1 light day from Earth. A signal from it takes a full day to reach us. In half a century of the fastest sustained travel we have ever managed, we have gone exactly 1 day, measured at the speed of light. Hold that number against where we are trying to go. The nearest star to the Sun, Proxima Centauri, sits a little over 4 light years away. Not 4 light days, 4 light years. At the speed Voyager is moving, the speed of our most distant machine, crossing that distance would take somewhere around 73,000 years. That is not a figure of speech. 73,000 years ago, our own species was still spreading out of Africa. The last ice age was grinding across the north, and nothing remotely like a city existed anywhere on Earth. A trip to the very nearest star, at our best sustained speed, is longer than the entire history of recognizable human beings. And Voyager is not even pointed at Proxima. It is just leaving in whatever direction it happens to face, into the dark. So before we say a single word about the expansion of the universe, about light speed, about horizons, we should be honest about the first wall, which is just the size of the gaps. The solar system, the sun and its planets, and the icy debris around them is the entirety of where human machines have ever been, and we have not even left its outer edge in any meaningful sense. Everything past it, every star you can see in the night sky, is separated from us by distances that turn travel into a project measured in tens of thousands of years at best. The stars are not waiting just over the horizon. They are oceans of empty space away, and we have crossed, so far, a single day of light. Now, I want to be fair because this first wall is the softest of all the ones we will hit tonight, and it is the only one where a clever answer even exists in principle. Voyager is slow by the standards of what is physically possible. There are ideas for going much faster, riding sails pushed by lasers, or other schemes that might one day reach a few % of the speed of light. which would cut a trip to the nearest star from 70,000 years down to a century or so. None of that is buildable now, and most of it is barely buildable on paper, but it is not forbidden by physics. So distance alone, the first wall, is the one limit in this whole subject that is merely extraordinarily hard rather than absolutely impossible. And that matters because it tells you the real walls are the ones underneath. Even if we solved the engineering, even if we built something that could cross to the nearest stars in a human lifetime, we would run straight into limits that no engineering touches, limits built into the fabric of space and time themselves. The distance to Proxima Centauri is a problem of speed, and speed has a ceiling we have not talked about yet. So before we get excited about going faster, we have to look at the wall that no amount of faster ever gets through, the fastest that anything in the universe is permitted to move. It is worth seeing just how far short our fastest falls. Voyager is quick by the standard of a thrown object, but it is not even the fastest thing we have ever made. That title belongs to a probe that swings close to the Sun and is whipped to enormous speed by the Sun's gravity, reaching something like 190 kilometers a second at its closest pass, more than 10 times Voyager's pace. And even at that speed, the speed of the fastest object human hands have ever flung, the nearest star would still be thousands of years away. We are not talking about a limit of one particular slow probe. We are talking about the fact that the very best we have ever done, at the very top of our ability, is still hopelessly outmatched by the plain size of the gap to the single closest star. And that gap to the nearest star is the small one. Within our own solar system, the distances already defeat intuition. Light, which crosses from the Moon to the Earth in a little over a second, takes more than 5 hours to travel from the Sun out to the orbit of distant Pluto. The cloud of icy bodies thought to surround the solar system at its outer edge may reach a full light year out, so that simply leaving the Sun's domain, before you have gone anywhere at all, is itself most of the way to the distance of the nearest star. Our entire home system, the only place our machines have ever touched, is already so large that light needs the better part of a day to cross it, and beyond its edge there is a gap of years of light to the very first thing out there. So the solar system is not a launching point we have stepped off of. It is a place we have barely finished crossing, after 70 years of spaceflight, with a single probe just now reaching one light day out. Everything we usually mean by space, the stars, the other suns, the rest of the galaxy, lies past a moat so wide that our fastest crossing of it would outlast every civilization that has ever risen and fallen on Earth, many times over. That is the first wall, the plain one, the one made only of distance, and it is already nearly absolute. The ones underneath it are worse. You may have heard that Voyager has left the solar system and entered interstellar space, and that is true in one specific sense and badly misleading in another. What it crossed is the edge of the Sun's bubble of wind and magnetic field, the boundary where the stream of particles flowing off the Sun gives way to the thin gas between the stars. That is a real frontier and a genuine milestone, but it is not the edge of the Sun's gravitational domain, which reaches vastly farther, out through the cloud of icy bodies that may extend something close to a light year in every direction. By that measure, Voyager has not left the Sun's neighborhood at all. It has crossed only the inner boundary of the Sun's own domain, a domain that may reach most of the way to the nearest star, and it will be tens of thousands of years clearing even that. So the headline that we have reached interstellar space hides the truth that we have barely begun to cross our own immediate surroundings. The space between the stars is not a line we have stepped over. It is an expanse so wide that our fastest craft, having flown for half a century, has covered a single day of light into it, with years of light to go before the very nearest star, and tens of thousands of years of travel to actually arrive. The wall of distance is not waiting out among the galaxies. It starts right here, in our own backyard, where even the gaps between neighbouring suns are already more than 100 human lifetimes of travel wide. And the nearest star is only the first step of a far larger emptiness, because even reaching it would not get us out of our own galaxy. The Milky Way is around 100,000 light-years across, a flat wheel of a few hundred billion stars, and Proxima Centauri is one of the very closest of those stars to us, a little over 4 light-years away. So crossing to Proxima, a trip of tens of thousands of years at our best speed, would carry us a single short stride across a galaxy 100,000 light-years wide. To cross the galaxy itself, at that pace, would take longer than the age of the universe many times over, and the galaxy is one of 2 trillion. The distances do not just defeat us at the scale of stars, they defeat us far more completely at every larger scale above that. There is a practical reason we cannot simply build something far faster than Voyager, and it sits underneath even the soft wall of distance. To go faster, a rocket has to carry fuel, and to carry more fuel it has to be heavier, and a heavier rocket needs still more fuel to push it. So the demands pile up against themselves, reaching even a small fraction of the speed of light by carrying and burning fuel would require amounts so enormous that no chemical rocket could ever do it, which is why the serious proposals abandon carried fuel altogether and dream of sails pushed from outside by beams of light. Even those, on paper, reach only a few % of light speed, turning a 70,000-year trip to the nearest star into a few centuries, still far beyond a single life, still only to the very closest star, still nowhere against the galaxy. The engineering wall and the distance wall reinforce each other, and together they pin us, in practice, very close to home. And the gap to the nearest star is not only long, it is empty, which removes the last comfort the frontier story might offer. On Earth, a long crossing has waypoints, islands, ports, places to stop and resupply. Between the Sun and Proxima Centauri there is essentially nothing. 4¼ light-years of near-perfect vacuum, a thin scatter of atoms and the occasional cold drifting body, and otherwise dark and empty space the whole way. There is no halfway station, no world to rest on, nothing to reach for in between. A crossing to the nearest star is not a chain of shorter hops. It is one unbroken plunge through tens of thousands of years of emptiness, with the home star shrinking behind and the target star not visibly growing for almost the entire trip. That is what every leap outward actually looks like, and it only gets worse with distance. The space between galaxies is emptier still, millions of light-years of almost perfect nothing between one island of stars and the next. So the universe is not a landscape dotted closely with destinations. It is a few small islands of matter separated by gulfs so wide and so empty that crossing even the narrowest of them to the single closest star outlasts civilizations. The distance wall is not just that the destinations are far, it is that between here and any of them lies an emptiness with nothing in it to make the crossing on, and that emptiness is the ordinary condition of the universe, the gaps being the rule and the islands the rare exception. And the dream of crossing those gaps with people aboard, in a great ship that carries generations who live and die in transit, runs into the emptiness in its own way. Such a ship would have to be a sealed world unto itself, making its own air and water and food, repairing itself with no port to call at, sustaining a living population for tens of thousands of years across a void with nothing in it, all without a single irrecoverable failure in any system across all that time. We struggle to keep machines running for decades. The crossing to even the nearest star, by any means we can actually conceive, would demand flawless function for far longer than recorded history, alone in the dark, with no help and no destination in sight for almost the entire span. The emptiness does not just have to be survived, it has to be survived perfectly, for longer than civilizations last. But distance is not the real wall. Even if we could move as fast as anything possibly can, a harder limit is already waiting, and it is not a matter of engineering or patience. It is a property of the universe itself, the speed at which the fabric of things allows anything at all to travel, and it turns every distance we just talked about from a long trip into something closer to a sentence. The speed of light is not a speed limit in the way a number on a road sign is a limit, something you could break if you only had a fast enough engine. It is the absolute ceiling on how fast anything can move through the universe, anything at all, including light, including information, including the fastest particle ever measured. Nothing with mass can be pushed all the way up to it, and nothing of any kind can go past it. This is not a gap in our technology. It is built into the structure of space and time, as fundamental as the fact that the past comes before the future. And that single fact turns every distance in space into a wall made of time. Here is what that means concretely when you look up. The light reaching your eyes from the sun left it about 8 minutes ago, so you never see the sun as it is, only as it was 8 minutes back. The light from Proxima Centauri is more than 4 years old by the time it arrives. The light from Andromeda, the nearest large galaxy to our own, left it about 2.5 million years ago, when nothing like a modern human yet walked the Earth, and only now is it landing in a telescope. The farther out you look, the deeper into the past you are seeing, until at the limits of the observable universe you are looking at light that has been travelling for most of the age of the universe itself. Sit with what that does to the idea of reaching any of it. You cannot even know what a distant galaxy looks like right now. You can only know what it looked like when its light set out, which for the far ones was billions of years ago. There is no faster channel, no special signal, no way to peek at the present state of a far place, because light is already the fastest messenger there is, and it takes that long. So distance in space is not like distance on Earth, where a far city is still happening at the same moment you are. A far galaxy is showing you a moment that ended before the Earth existed, and the only way to get a fresher look is to wait, while the light that is already on its way keeps crawling toward you across the years. And this is where the first wall and the second wall combine into something worse than either alone. The distances are enormous, tens of thousands of years of travel even to the nearest star, and the fastest anything can cross those distances is locked by the laws of physics at the speed of light, which for anything we could actually build means a small fraction of even that. So the galaxy is not just far, it is far, and the crossing speed is capped, and the cap is not negotiable. Every dream of spreading across the stars runs into this, because the numbers do not get better with cleverness past a certain point. There is a fastest, and it is fixed, and even it is agonizingly slow against the size of what is out there. I should be honest about the loopholes people reach for, because they come up every time. Wormholes, warp drives, ways of folding space or skipping through it, all of these appear in serious physics as mathematical possibilities under conditions we have never observed and have no way to create. Not one of them has any experimental support. Not one has ever been shown to be more than equations that might describe something the universe may not actually permit. To plan an escape on them is not science, it is hope wearing the costume of science. On everything we have ever measured, the speed of light is the ceiling, and it does not lift. There is a consequence of the light barrier that goes deeper than slow travel, and it is about contact of any kind. Because light is the fastest carrier of information, the speed limit is not just a limit on ships, it is a limit on conversation, on signal, on cause and effect itself. If something happens at a far galaxy, the soonest we could possibly know is set by how long its light takes to reach us, which for the deep ones is billions of years. And the soonest we could answer is that same span again. So even setting travel aside entirely, even imagining we only wanted to send a message, the distances and the light barrier together mean that a single round of hello and reply with anything truly far would take longer than the Earth has existed. There is no holding a conversation across the universe. There is barely the possibility of a one-way word arriving, ages late. This is why the light we gather from the deep universe is less a view of the present than a kind of fossil record. The most distant galaxies in our deepest images appear as they were when the universe was a small fraction of its current age, their light having travelled for over 13 billion years to reach us. We are not seeing young galaxies, we are seeing old light from galaxies that, if they still exist, have lived billions of years of history we will never witness, because the news of that history is crawling toward us no faster than light, and most of it will never arrive at all. Everything far is shown to us only in its deep past, and the gap between that past and its unknown present is a gap we can never close. So the second wall is not only that travel is capped, it is that the cap turns the whole far universe into a record of things that already happened, viewed across delays so long that the present state of anything distant is permanently hidden. We do not get to know what is happening out there now. We only get the light that left long ago, telling us what was happening then. The universe denies us not just the ability to go, but the ability to know, in any current sense, what the far reaches are even doing. And against this fixed wall, the universe then does something that makes it all worse. It moves. Follow the light barrier to one of its starkest consequences, the one for the old dream of meeting someone else out there. Suppose the universe holds other civilizations scattered across distant galaxies. The light barrier means that even a single exchange signal, a hello sent and an answer received, would take, for anything in a far galaxy, longer than the age of the Earth. There is no negotiating that down. It is set by the speed of light and the size of the gaps, both of which are fixed. So the picture from the frontier story of a universe knit together by travel and contact, a community of worlds, is not merely beyond our technology, it is forbidden by the structure of space and time. Anyone far is not just unvisited, they are uncontactable, sealed in their own region by the same walls that seal us in ours. And the expansion makes even that too generous, because it means the far civilizations are not merely distant but receding, many of them already beyond the line where any signal could ever pass between us in either direction, ever. So the universe is not a place where intelligence, if it exists, forms a network. It is a place where each island of it, if there is more than one, is causally cut off from the others, able at most to catch the ancient light of the rest, never to touch it or speak to it. The walls do not only trap us, they trap everyone, separately, in their own small bound region, with the growing dark between. There is one genuine loophole in the light barrier, and it is worth being honest about because it is real, and it still does not save us. If you could travel very close to the speed of light, time for you would slow relative to the universe, so that in principle a traveller could cross enormous distances within their own lifetime, even as thousands or millions of years passed outside. That much is true and not science fiction. But notice what it costs and what it does not buy. The traveller who crossed to a distant galaxy that way would arrive in a universe aged by all the time the trip really took, with everything they left behind long gone, and they could never return to the world or the era they came from. And it still does nothing against the horizon, because the galaxies past that line recede faster than light, so no closeness to light speed, however extreme, ever reaches them. The loophole shortens some trips for the traveller, it does not open the prison. Hold one concrete instance of the delay to feel it properly. The Andromeda Galaxy is the nearest large galaxy to ours, and its light takes about 2.5 million years to reach us. So the Andromeda you can find in the sky is the Andromeda of 2.5 million years ago, when our own ancestors were not yet recognisably human. Whatever is happening in Andromeda tonight, the actual present of that galaxy will not be visible from Earth for another 2.5 million years, long after everything alive now is gone. And Andromeda is the close one, the neighbour practically next door. For the galaxies that fill the deep images, the delay is not millions of years but billions, so that we see them as they were before the Earth had formed. The far universe reaches us only as a deep archive of the past, never as a present we could act on. Follow the light barrier all the way out, and it leads somewhere strange, to the edge of the observable universe itself, which is really the edge of how far back we can see. The most distant light of all is the faint glow left from when the universe first became transparent, light that has travelled for over 13 billion years to reach us. Look that far, and you are seeing the universe in its infancy, before any galaxy existed. But the regions that emitted that ancient light are now, after all the expansion since, the most hopelessly distant and fastest receding places of all, far beyond any horizon we could ever cross. So the deepest thing we can see is also the most absolutely unreachable, the baby picture of regions whose grown forms are sealed away more completely than anything else in existence. To look as far as it is possible to look is to look at what we could never, under any circumstances, reach. A fixed speed limit in a fixed universe would at least be a wall you could chip at slowly, sending out machines that crawl across the millennia, building up a reach one painful light year at a time. But the universe is not fixed, and this is where the whole picture turns from merely hard to genuinely sealed. The space those machines would have to cross is not sitting still and waiting, it is growing. The gaps themselves are getting wider all the time, everywhere at once. The universe is expanding. Not expanding into something, not blowing outward from a center like debris from an explosion, but expanding everywhere at once, the space between things stretching so that distant galaxies grow farther apart with every passing moment. This is one of the most solid facts in all of physics, measured countless ways, and it changes everything about the question of reach, because it means the distances we have been talking about are not fixed numbers. They are growing while we look at them. The pattern is simple and strange. Every distant galaxy is moving away from us, and the farther away a galaxy is, the faster it recedes. A galaxy twice as far away moves away twice as fast. This is exactly what you get if space itself is stretching uniformly, because then the more space there is between you and something, the more total stretching happens across that gap, and the faster the distance grows. It is not that those galaxies are flying through space away from us. It is that the space between us and them is swelling, carrying them along with it, like marks drawn on something being stretched in every direction. And here is the part that turns expansion from an interesting fact into a wall. The expansion is not slowing down, it is speeding up. For most of the universe's history, the expansion was gradually decelerating, as the gravity of all the matter in the universe pulled back against it. But several billion years ago, something won out, a property of empty space we call dark energy, and the expansion began to accelerate. The gaps are not just widening, they are widening faster every year. Dark energy makes up most of the total content of the universe, far more than all the stars and gas and dark matter combined. And as space expands, there is simply more space, and so more dark energy, and so more push. The acceleration feeds itself. I have to be plain about how much we do not understand here, because it matters and because this channel does not paper over the holes. We can measure dark energy's effects with great precision. We can see the expansion accelerating, track it across billions of years, and model it as a constant energy built into every cubic meter of empty space. But what it actually is, why empty space should carry an energy that pushes the universe apart, is one of the deepest unsolved problems in all of science. We are in the position of knowing exactly what something does and having almost no idea what it is. And what it does is widen the gaps, faster and faster, between us and everything beyond our own small bound corner. So now stack the three walls. The distances are enormous. The speed to cross them is capped at light and realistically far below it, and the distances themselves are growing faster all the time, pushed by something we cannot explain. Each wall alone would be daunting. Together they start to close off the universe in a way that no amount of patience or engineering can answer, because you are trying to cross a widening gap at a fixed top speed, and the widening never stops and only quickens. The question that forces itself next is the obvious one. If the gaps are growing, is there a point where they grow faster than anything could ever cross them? And the answer is yes. It is worth being clear about how we know the expansion is real and accelerating, because it is one of the most carefully established facts in science. The first piece came from seeing that nearly every distant galaxy has its light shifted toward the red end of the spectrum, stretched to longer wavelengths exactly as you would expect if the space the light travelled through had been growing while it crossed. The farther the galaxy, the greater the stretch, in a clean relationship that points straight to expanding space. That much has been known for most of a century. The acceleration came later and was more of a shock. By measuring the brightness of a particular kind of stellar explosion in distant galaxies, a kind whose true brightness is known, it became possible to gauge how far away those galaxies really were and how fast the expansion was going at different times in the past. The expectation was that the expansion would be slowing, dragged on by the gravity of all the matter in the universe. Instead, the distant explosions were dimmer and therefore farther than a slowing universe would put them. The expansion had been speeding up. Something was pushing space apart harder over time, not gentler, and that something is what we now call dark energy. And the unsettling thing about dark energy is how it scales. It appears to be a property of empty space itself, a fixed amount of outward push in every region of vacuum. So as space expands and there is more vacuum, there is more total dark energy and more push, and so faster expansion, which makes more space still. It is a process that feeds on its own product. The more the universe grows, the harder it is driven to grow, which means the widening of the gaps between us and everything beyond our bound neighborhood is not steady but quickening, and will go on quickening for as long as dark energy stays what it is. That is the engine behind every wall still to come. One point clears up a common confusion and sharpens the picture. The expansion does not stretch everything. It does not pull atoms apart, or stretch the Earth, or widen the solar system, or even pull apart a galaxy or a gravitationally bound group of galaxies, because in all of those, the local forces, the electrical bonds, the gravity, are far stronger than the gentle outward tendency of the expanding space, and simply hold things together. The expansion only wins in the great gulfs between the bound structures, the open space between galaxies and clusters that are not held to one another by gravity. So it is specifically the distances between us and the unbound galaxies, the ones not in our own gravitational group, that grow. Those are exactly the distances that matter for reaching the wider universe, and those are the ones widening without limit. That is why the prison has the particular shape it does. Everything bound to us, our galaxy, our local group, holds together and stays. Everything not bound to us recedes. The expansion draws a sharp line between the small region gravity has locked to us and the immense region it has not, and it pushes the second away faster and faster while leaving the first intact. So the universe does not simply drift apart uniformly. It separates into bound islands that survive and an ever-widening void between them that nothing can cross, and we are left holding one island while the rest of what we can see streams away beyond the gulf. Run the acceleration forward, and it does something stark to the shape of the future, because dark energy drives the expansion to speed up. The growth of the gaps is not steady but compounding, the kind of growth that doubles and doubles again, so that distances between unbound structures do not just increase but increase ever faster without end. In the deep future, this means the space between any two galaxies that are not gravitationally bound grows without limit and at an accelerating rate until they are flung apart beyond all contact. The universe is headed toward a state of relentless accelerating separation, where every island of matter that is not held together by its own gravity is driven away from every other, faster forever. That is the engine that empties the sky, and it does not wind down, it winds up. One feature of the expansion removes any comfort we might take from being a special victim of it. The expansion has no center, and it looks the same from everywhere. From any galaxy in the universe, an observer would see all the other unbound galaxies receding from them, the farther ones faster, exactly as we do. We are not at some unlucky spot from which everything flees. Every spot is that spot, so the closing we are describing is not a local misfortune. It is the condition of the entire universe, the same for every island of matter in it, each one watching the rest recede, each one being sealed into its own bound region by the same growth of space. The prison is not ours alone, it is the shape of the whole, and every inmate sits at the apparent center of their own shrinking cell. The accelerating expansion is also slowly draining the universe toward a colder, emptier state, and that is part of what the closing means. As everything unbound flies apart faster and faster, the universe spreads its matter and energy ever thinner across ever more space, trending over immense spans of time toward darkness and cold. The galaxies that remain bound will burn through their gas, their stars will age and die, and no fresh material will arrive from outside because everything outside is receding beyond reach. So the expansion does not only isolate each island, it ensures that each island is in the long run a closed and dwindling stock, with no resupply possible from the rest of a universe that has fled. This is the deep direction of things, the way the universe is actually headed, underneath the bright sky we see now, not toward connection and spreading and filling, the way the frontier story imagines, but towards separation, isolation, and a slow thinning out, as the accelerating growth of space carries everything away from everything else and leaves each bound remnant alone with what it has. We happen to live while the islands are still rich and the sky is still full, but the trend is set, and it runs the other way from every hopeful story we tell about the future out there. The universe is not gathering, it is dispersing, faster all the time, and the closing of our reach is one face of that single, universe-wide coming apart. The expansion has a measurable pace, and putting rough numbers to it shows how quickly the recession piles up. For every few million light-years of distance, a galaxy's speed of recession grows by a set amount, so that by the time you reach a galaxy a billion light-years away, it is already receding at a sizable fraction of the speed of light, and the trend continues straight upward with distance. Keep going out and you reach the point, around 14 billion light-years, where the accumulated recession equals the speed of light itself, and past that it exceeds it. None of this requires any galaxy to do anything unusual. It is simply the steady stretching of space, the same gentle rate everywhere, adding up across larger and larger gaps until the total outruns light. The faster-than-light recession of the far universe is not an exotic event, it is ordinary expansion, summed over an extraordinary distance. And if the space between us and a galaxy grows fast enough, then the gap between us can open faster than light itself can close it. That sounds like it should be impossible, like it breaks the very speed limit we just called unbreakable. It does not, and understanding why is the key to the whole prison. Because past a certain distance, the expansion is already doing exactly that, to most of the universe right now. Beyond a certain distance, the expansion of space carries galaxies away from us faster than the speed of light. That sentence sounds like it cannot be true, because nothing can move faster than light, and nothing can through space. But this is the subtle and crucial point. Those galaxies are not moving through space faster than light. The space between us and them is stretching so much, across such a large gap, that the total distance grows faster than light can cross it. No rule is broken, because the galaxies are barely moving relative to the space right around them. It is the space itself, the sheer amount of it between us, that is doing the receding. There is a distance where this kicks in, called the Hubble radius, and it sits about 14 billion light-years away. Inside it, galaxies recede from us slower than light. Past it, they recede faster, simply because there is more expanding space between us and them, and all that stretching adds up past the speed of light. And the great bulk of the observable universe lies past that line. Most of the galaxies we can detect are, right now, receding from us faster than light, carried off by the swelling of the space in between, faster than any signal could ever chase them down. Now think about what that does to the possibility of ever reaching them. Consider a beam of light leaving us tonight, aimed at one of those galaxies. The galaxy is receding faster than that beam can advance, because the space the beam has to cross is growing faster than the beam moves across it. The beam makes progress, and the gap grows faster than the progress, so the beam loses ground forever. It never arrives, not in a billion years, not in a trillion, not ever. And if light cannot get there, then nothing can, because light is the fastest thing there is. A galaxy past that line is not far. It is unreachable in the strict and final sense, sealed off by the growth of space at a rate that beats the only speed that matters. I want to be careful here, because the honest picture has a wrinkle that matters. We can still see many galaxies that are receding faster than light. That sounds like a contradiction, but it is not. The light we see from them left long ago, when they were closer and the geometry was different, and it has been crawling toward us across all the time since. So the sky is full of light from galaxies that we can see but can no longer reach. Light that got out before the door closed. Seeing the old light and being able to send anything back are two completely different things. The image arrives, the reply never could. And the boundary between what we can still reach and what we have lost is not vague. It is a real, calculable line, and the unsettling truth is how much of the universe is already on the wrong side of it. We tend to assume that if we can see something, then in principle, given enough time and speed, we could get there. For most of what we can see, that assumption is simply false. The light is a message from a place we were never going to be able to touch, sent before we existed, arriving now from the far side of a wall that the expansion built and keeps building higher. There is an image that helps hold this straight, and it comes from the physics itself, not from metaphor. Light trying to reach us from a galaxy beyond the Hubble radius is like a swimmer striking out across a river toward a far bank, except the river itself is widening faster than the swimmer can advance. The swimmer is doing everything right, moving at full speed through the water around them, but the water around them is being carried away, and the far bank only gets farther. That is the exact situation of a photon released now toward a galaxy beyond the line. It moves through the space immediately around it at the speed of light, always. But that space is being swept away from us faster than the photon gains, and so the photon falls behind forever. And this is why seeing and reaching come completely apart out there. We have to keep the two ideas separate, because intuition fuses them. On Earth, if you can see a mountain, you can in principle walk to it. In the expanding universe, that link is broken past a certain distance. We see the old light of galaxies that are now receding faster than light, light that escaped toward us long ago when the gap was smaller, and that light is still arriving, a message from a sender we can no longer answer or reach. The image in the telescope is real, and the galaxy behind it is real, but the path between us and it has been cut by the growth of space, and no new thing can ever travel that path again in either direction. So when we ask how much of the universe is already lost, we are not asking how much is too dim to see or too far to have noticed. We are asking how much has already slipped past the line where the expanding space between us is winning against light itself. And the honest accounting of that is the heart of this whole subject, the number that turns a story about distance into a story about a prison. It is time to look at that number directly, because it is larger and crueler than almost anyone expects. The visible signature of all this is redshift, and it is worth knowing how directly we read it, because it is what turns the whole story from theory into measurement. As light crosses the expanding space between a distant galaxy and us, the space it is traveling through stretches, and the light stretches with it, its waves drawn out to longer, redder wavelengths by the time they arrive. The more space the light crossed, and the more that space grew during the crossing, the greater the stretch. So the redshift of a galaxy is a direct readout of how much the universe expanded while its light was on the way, and the most distant galaxies we detect show enormous redshifts. Their light stretched many times over. And that stretch tells you something brutal about where those galaxies are now, as opposed to where their light shows them. The light from a far galaxy left when the galaxy was relatively close early in the universe's history. By now, the expansion has carried the galaxy itself far beyond the position its old light suggests, in many cases past the horizon entirely. The newest deep telescopes can capture galaxies as they were in the first few 100 million years after the beginning, which sounds like reaching across the universe, and it is, but only across the universe as it was. The present-day versions of those galaxies, if they survive, sit at distances so great, receding so fast, that they are among the most hopelessly unreachable things in all of existence. We are photographing the infancy of objects whose adulthood is sealed away from us forever. It helps to hold on to one precise idea about that boundary. The galaxies past the line are not receding faster than light because they are moving through space at impossible speeds. Each of them, in its own neighborhood, sits nearly still relative to the space around it, no faster than the gentle drift of any galaxy. The faster-than-light recession is entirely the sum of all the expanding space stacked up between us and them, a great many small stretchings adding into a total that grows faster than light can cross. This is why it breaks no law. Nothing local exceeds light. It is only the accumulated growth of the whole long gap that does, and that accumulation is exactly what light, crossing the same gap, cannot overcome, because it is fighting the very stretching that defines the distance. There is a specific way a galaxy disappears as it approaches the horizon, and it is worth seeing, because it is gentler and stranger than going dark all at once. As the expansion carries a galaxy toward the boundary, its light is stretched further and further toward the red, its image dimming and reddening, the rate of its clock as we see it slowing, so that it appears to fade and freeze rather than wink out. It never quite seems to cross in our view. Instead, it grows ever redder, ever fainter, its last light smeared across longer and longer wavelengths, until it slips below anything our instruments could detect and is for all purposes gone. So the galaxies do not vanish with a sharp edge. They redshift into invisibility, fading like an after image, leaving the sky a little emptier each age, in a way too slow for any eye to catch. There is a distinction worth holding here between the limit of what we can see and the limit of what we can affect, because they are not the same line, and the gap between them is most of the sky. The boundary of what we can see is set by how far light has had time to travel to us since the beginning, and it is enormous. The boundary of what we can reach or signal going forward is the cosmic event horizon, and it is much closer in. Between those two boundaries lies a great shell of the universe that we can see but can never touch, galaxies whose ancient light reaches us while anything we might send toward them never arrives. So the universe we can observe is far larger than the universe we can ever interact with, and the difference is not a sliver at the edge. It is the bulk of everything in view, which forces the real number. If the walls are moving away faster than light, then how much of the universe is already behind them, already gone, already past any reach we could ever have? It would be comforting to think it is the far fringe, the most distant sliver, with the bulk of what we see still in play. It is the other way around. The part still in reach is the sliver. Almost everything we can see is already lost. Here is the number, and it is the hardest fact in this whole subject. Of all the galaxies we can see in the sky, the ones whose light fills our telescopes, only around 3% are still reachable. The other 90-some% are already gone, already past the line beyond which nothing we send could ever arrive. If we launched a beam of light today toward the great majority of the galaxies we can observe, it would never get there, no matter how long the universe lasted. We can see them, we cannot reach them, and that was already true before you were born. This comes from a real boundary called the cosmic event horizon. It sits at a proper distance of around 16 to 17 billion light years, and it marks the edge of what we can ever affect. Anything we send now, even at the speed of light, can only ever reach things inside that line. Everything past it is causally sealed away from our future, forever. The trouble is the scale of what lies past it. The observable universe reaches out to about 46 billion light years in every direction, and it holds something like 2 trillion galaxies. The event horizon, the reachable line, encloses only a small core of that enormous sphere. The overwhelming majority of those 2 trillion galaxies are already outside it. So when you look at an image of the deep universe, thousands of galaxies scattered across a single patch of sky, understand what you are actually looking at. Almost every one of them is unreachable, not in practice, but in principle, forever, by anything we could ever do or build or become. The light is real. It genuinely came from those galaxies, but it shows them as they were billions of years ago, and in the time that light spent traveling, the expansion carried those galaxies so far that they crossed the horizon and can never be reached. You are looking at light from places that are, for us, already gone. The sky is a gallery of ghosts, images still arriving from galaxies we lost before we knew they were there. I have to be honest about the precision, because the exact number moves depending on how you count. Whether you measure by galaxies or by volume, and exactly which cosmological values you use, shifts the figure somewhat, and you will see 3% in one place and a slightly different small number in another. But every honest version of the calculation lands in the same place, and it is brutal. The reachable part of the universe is a small minority of what we can see. The unreachable part is almost all of it, and as we will see, that small reachable minority is not even holding steady. It is shrinking. It helps to separate two things we casually run together, the observable universe and the reachable universe, because the gap between them is the whole point. The observable universe is everything whose light has had time to reach us since the beginning, a sphere reaching out about 46 billion light years in every direction, packed with around 2 trillion galaxies. That is what we can see. The reachable universe is something far smaller, the region we could still send something to, even at the speed of light, given all the time the universe has left. That region reaches only to the cosmic event horizon, and it encloses a small core of the observable sphere. Everything between that core and the visible edge is seeable but unreachable, and that in-between zone is most of everything. Run the geometry and the smallness of the reachable part becomes stark. The reachable region extends to a co-moving distance of roughly 18 billion light years, while the observable universe extends to about 46. Because volume grows with the cube of distance, a region reaching only a little over a third as far holds only a few % of the total volume. So even though we can see 2 trillion galaxies, the number we could ever actually send anything to is a small slice off the near edge of that, a few % at most, with the rest forever beyond the line. The sky is enormous. The part of it we could ever touch is a thin shell close around us and shrinking. And the cruelty of it is how complete and how quiet the ceiling was. There was no moment we could have caught, no closing door we might have rushed through with a faster ship. For the great majority of those galaxies, the door was already shut before humans existed, before the Earth existed, set by the expansion that has been running since the beginning. We did not miss our chance to reach them. We never had one. The light that makes them visible is the only thing about them that was ever going to reach us, and it is a one-way delivery from places that were never, in any sense that matters, within our grasp. Let the difference between a big universe and an available universe sink in, because the frontier story quietly swaps one for the other. When we marvel at 2 trillion galaxies, we are marveling at how much there is, and there is an unimaginable amount. But how much there is and how much is ours to reach are entirely different quantities, and the second is tiny. The 2 trillion is the size of the view. The reachable portion, a few percent at most, is the size of the world. We have been told a story about the first number, the immensity, and encouraged to feel that it is all out there waiting. Almost none of it is. The immensity is real, and it is mostly a picture, light arriving from places we were never going to touch. And the few percent that is reachable is not a stable holding either, which is the part that turns a sad fact into a closing one. That 3% is the most that will ever be reachable, the high watermark measured now. Everything about the future subtracts from it, so even the small available universe is not a territory we can settle into and count on. It is a balance being drawn down, the largest it will ever be at this very moment, with every future age inheriting less. We do not stand at the start of an age of expansion outward. We stand at the maximum of access, with the whole of the future being a slow accounting of loss. Put the two numbers side by side one more time, because their ratio is the whole argument. 2 trillion galaxies in the sky we can see. A few percent of them at most still reachable by anything we could ever send. That means for every galaxy we could in principle still touch, there are something like 30 we can see and never reach. 30 whose light is a delivery from a place sealed off before we existed. When you look at a deep image of the universe and see it crowded edge to edge with galaxies, the honest caption is that nearly every point of light in it is already gone from us, present only as an image, a record of a place that left our reach long ago. We did not lose them through any failure. We were shown them only after they were already lost. It is worth naming the quiet swap the frontier story performs, because once you see it, you cannot unsee it. It points at the immensity, the 2 trillion galaxies, the unimaginable scale, and it lets that immensity stand in for opportunity, as if all of it were a territory we might one day move through. But scale is not access. The universe being immense tells you how much there is to look at, not how much there is to reach. And those numbers are wildly different. The amount to look at is 2 trillion galaxies. The amount to reach is a few percent of that. And falling. The immensity is real, and it is almost entirely a view, a thing seen and not had. The story sells us the size and quietly lets us believe it is ours, when nearly all of it was sealed away before we drew our first breath. It is worth realizing how recently we learnt any of this, because it is part of why it still has not sunk into how we talk about space. That the expansion is accelerating was only established within the last few decades, from careful measurements of distant stellar explosions, and the full consequence that most of the visible universe is already unreachable and the reachable part is shrinking, is a piece of understanding younger than many of the people hearing it. For nearly all of human history we assumed, reasonably, that the universe was at least reachable in principle, that to see a thing was to have some claim on one day going there. That assumption is now known to be false for the overwhelming majority of what we can see, and the knowledge is so new that our stories, our ambitions, our sense of space as an open frontier have simply not caught up to it. So the spike of this whole subject is not only the number, the 3%, the ghosts. It is the recency and the strangeness of the realization itself that we have just in the last eye blink of our history discovered that the universe we thought was our future was mostly never available, that the door closed on the great bulk of it before we existed, and that we found out only now by measuring the fading light of distant explosions. We are the first humans to know that we live in a closing universe rather than an open one, and we are still, most of us, talking as though we did not know it. The fact is the reframing has not finished arriving. There is a single image that holds the whole of this, and it is one we make all the time, the deep field, a long exposure of a tiny dark patch of sky that fills with thousands of galaxies, each one a great wheel of hundreds of billions of stars. We hold those images up as proof of how much is out there, and they are. But the honest reading of them is harder. Nearly every galaxy in that frame is already beyond our reach, sealed past the horizon, present in the image only as old light from a place we lost before we knew it existed. The deep field is not a map of destinations. It is a portrait gallery of the departed, a long exposure of light from the far side of a wall, and the more galaxies it reveals, the more thoroughly it shows us exactly how much was never ours. And notice how generous the definition of reachable already is, which makes the 3% even starker. To count a galaxy as reachable, we are not asking whether we could get there soon, or in a human lifetime, or even in the current age of the universe. We are asking only whether a signal sent now at the speed of light could ever arrive, given the entire infinite future of the universe to do it. That is the most forgiving test imaginable, light speed and all of eternity, and the great majority of galaxies fail even that. They are not unreachable merely in practice, or unreachable within any sensible span. They are unreachable under the kindest possible terms physics allows, with the fastest possible messenger and unlimited time. And still the answer is no. The 3% is not what we can reach soon. It is what we could ever reach at all, under the best case the universe permits, and it is almost nothing. So the honest way to hold the size of the universe is in two numbers at once, and to never let the first one hide the second. The first number is how much there is, 2 trillion galaxies, an immensity beyond any feeling. The second number is how much of it could ever be ours, a few percent and falling. The frontier story keeps showing us the first number and letting us assume it means the second. It does not. The universe is immense in how much it contains and tiny in how much it offers, and the gap between those two facts is the whole truth of our situation, an enormous view wrapped around an almost empty allowance. This is the wall that has already closed, and it closed around almost everything. Not a wall we are approaching, not a wall in our future, but one that sealed off the great majority of the universe long ago, quietly, while the light from the far side kept arriving to make it look as though those places were still somehow ours. They never were. The universe we can touch was always a small core inside the universe we can see, and the universe we can see was always a small core inside the whole. Most of it was never available to us. We just could not tell, because the ghosts kept shining. We have just crossed the hardest fact in this whole subject, that most of the universe is already beyond anything we could ever reach. So hold one question from here because it decides how dark this gets, and I will answer it before the end. Does the wall stop where it is now, leaving us most of what we can see to at least look at, or does it keep closing, taking even the view? Hold that. The answer is not the one you would hope for. The reachable part of the universe is not even holding still. It is shrinking. Every year, galaxies that are reachable today drift a little closer to the cosmic horizon, and some of them cross it, leaving the reachable region for good. Because the expansion is accelerating, this is a one-way process. A galaxy that slips over that line never comes back, never becomes reachable again, because the thing carrying it away is only getting stronger. The small, reachable minority we just described is the largest it will ever be. From here, it only gets smaller. The numbers are quietly merciless. The fraction of the observable universe we could still reach drops measurably even on the timescale of 1 billion years, sliding down a percentage point or so as more galaxies pass beyond the line. Stretch that out over the longer future, and the reachable region collapses toward almost nothing, as more and more of what is currently in play accelerates past the horizon and is gone. The universe is not a fixed territory we have failed to explore. It is a territory actively contracting, and the contraction is built into the same dark energy that drives the expansion. The more space expands, the more dark energy there is to push it. The faster the gaps widen, the more crosses the line. Consider the situation from a galaxy near that boundary, one still barely reachable today. The space between it and us is widening faster every year, and at some point the widening tips past the speed of light, and in that moment the galaxy passes from the column of things we could in principle still reach into the column of things we have lost forever. Nothing dramatic happens to the galaxy itself. It does not change. It is the gap that changes, crossing a threshold, and on our side of that threshold, a possibility quietly dies. That is happening somewhere on the boundary all the time. The reachable universe is leaking away at the edges, galaxy by galaxy, and there is no plugging the leak. I will give the honest caveat, because it is real. All of this assumes dark energy keeps behaving the way it does now, as a constant property of space, driving a steady acceleration. That is our best current model, and it fits the data well, but the nature of dark energy is unknown, and if it turned out to change over time, the long-term picture could differ from what the standard model predicts. There is, at present, no evidence that it does change, and every measurement we have is consistent with it staying constant, so the shrinking is the honest expectation, not a certainty about the deep future, and I will not pretend otherwise. But on everything we actually know, the cell is closing in. Try to feel the rate of the loss, even though the human scale and the cosmic scale barely touch. Galaxies are crossing the horizon, leaving the reachable region continuously in a steady outward bleed. By some accountings, on the order of 100 billion stars worth of galaxies slip past that line every year, gone from the column of things we could ever reach into the column of things we have lost. The exact bookkeeping depends on how you count, but the direction is fixed and the process never pauses. The reachable universe is not a fixed allotment we have failed to use. It is an account being drained every year by the expansion, and the withdrawals are permanent. And the timing of where we sit is its own quiet wait. The reachable universe is, right now, the largest it will ever be. Every future moment has less in it than this one. There is no point in the entire future of the universe where we, or anyone, get to reach more than is reachable today, because the only motion is outward, across the line, away. Whatever we did not reach by now, we will reach a little less of with each passing age. We are not early in a growing story of expansion into the universe. We are at the high watermark of access, watching the tide go out, and it does not come back in. This is what it means to say the wall is closing, rather than merely standing. A fixed prison, however small, at least holds steady, and you can map it and know its limits and make your peace with them. This one contracts. The territory available to anything that ever lives in this universe is shrinking on a cosmic clock, slowly by our measure, but without pause or reversal, and the same dark energy that built the walls keeps drawing them inward. So the honest question is not how much of the universe we can reach. It is how little will be left to reach by the time anything could try, and where the shrinking finally bottoms out. To see the ratchet clearly, think of the boundary as a line drawn through the sky, with reachable galaxies on the near side and lost ones on the far side, and the line creeping inward year by year. A galaxy sitting just inside the line today is reachable in the sense that something we launch now at light speed could, after an enormous span, arrive, wait long enough, and the expansion carries that same galaxy out across the line, and from that moment it is lost, and no later effort, no faster launch ever recovers it, because the line only moves one way. There is no mechanism in the physics that pushes a galaxy back from lost to reachable. The accounting runs in a single direction, debit only, and it never closes for the day. This is why the present moment is in a strict sense privileged, and not in a comforting way. Anything we ever hope to reach, we must reach from a starting point no later than now, because now is when the reachable universe is at its largest. Every year we wait, the set of achievable destinations shrinks as more of them slip past the line. It is the one deadline in the universe that cannot be extended, because it is enforced by the expansion of space itself. And against that deadline, our actual reach, one light day in 50 years, is so small that the shrinking of the reachable universe is, for any practical purpose, simply the steady confirmation that nearly all of it was never going to be ours. And the cruelty of the timing is that the loss is invisible while it happens, hidden behind the steady arrival of old light. A galaxy that crossed beyond our reach a billion years ago still shines in our sky tonight, its light from before the crossing still arriving, looking for all the world like a place we could aim for. So the sky gives no sign of the closing. It looks full, open, available, exactly as a frontier should look, while in truth most of what fills it is already behind the wall. The expansion does its sealing quietly, out past the reach of any view, and leaves the comforting light in place to arrive for ages afterward. We are looking at an open frontier that closed long ago and has not yet gone dark. And there is a deadline buried in this that is unlike any other, because it cannot be extended by anyone or anything. Whatever the reachable universe will ever be reached from, it has to be reached starting no later than now, because the reachable region only shrinks. Every destination that is still in reach today is in reach for a limited time, and once the expansion carries it across the line, no later effort recovers it. Not in a billion years, not ever. So this is the one deadline in existence enforced by the structure of the universe itself, the same for everyone, immovable, counting down as the gaps widen, and set against our actual reach. One light day in 50 years. The deadline is almost a formality. Nearly everything was already past it before we could have tried. There is a plain way to say where we sit in all of this, and it is not flattering to the frontier dream. We are at the moment of maximum access. Never again in all the future of the universe will as much be reachable as is reachable right now, because the only motion is loss. Galaxies crossing the line and never returning. So if you lay out the entire span of cosmic history as a long descent of shrinking reach, we are near the top of it, holding the largest allotment any observer will ever hold and watching it diminish. That is not the position of explorers at a dawn. It is the position of heirs at the reading of a will that only ever subtracts, present for the one moment when the estate is largest, before the long dwindling begins. And the dwindling is not gentle in its meaning, even if it is slow on the clock. Every galaxy that crosses the horizon is a destination that was, in principle, on the table and is now permanently off it. A possibility extinguished not by our failure, but by the structure of the universe. The list of places anything from here could ever reach is being shortened, line by line, forever. And it is being shortened from a list that was already, against the size of the sky, heartbreakingly short. We are not failing to seize an expanding opportunity. We are watching a small and fixed opportunity quietly contract, with no way to slow it, and nowhere the contraction stops, short of almost nothing. There is a direction to this in time that makes our own position clearer and sadder. The reachable universe has not always been shrinking from a fixed start. Earlier in cosmic history, before the acceleration took firm hold, an observer could in principle reach a larger share of what they saw than we can now, because the expansion had not yet carried so much beyond the line. So reach has been declining across cosmic time, and every era inherits a more sealed universe than the one before. We have less reach than observers in the distant past would have had, and more than any who come after. We are not at the beginning of access then, but somewhere on its long downslope, holding more than the future will, and less than the past did, in a decline that began before us and continues without pause after. So the wall is not a fixed boundary we are trapped inside. It is a boundary moving steadily inward, taking more of the universe out of our reach with every year that passes. And that raises the question that decides how this story ends. If the reachable universe is shrinking, then run the shrinking forward. Keep losing galaxies across the line faster and faster for billions of years. What is left at the end of that? When the contraction has run as far as it goes, what, if anything, do we actually get to keep? The answer is our own neighborhood, and nothing else. There is one thing that holds out against the expansion, and that is gravity, where it is strong enough. Our galaxy, the Milky Way, is bound by gravity to a small collection of nearby galaxies called the local group, around 50 of them in all, dominated by us and by the Andromeda galaxy with a few dozen smaller ones gathered around. These galaxies are gravitationally bound to one another, which means gravity between them is winning against the expansion trying to pull them apart. They are not receding from each other. They will stay together while everything else goes. And in a few billion years, the two giants of that group, the Milky Way and Andromeda, will fall together and merge. They are approaching each other now, and eventually they will pass through one another, their stars sliding past in the dark, and over a long while they will settle into a single larger galaxy. The smaller members of the local group will remain bound to that merged remnant. That combined island of stars, the merger of our galaxy and its nearest large neighbour, along with their bound companions, is the entire territory that will ever remain within our reach. That is it. That is what we keep. Set that against what we are losing. The local group is around 50 galaxies. The observable universe holds something like 2 trillion, so the part that stays bound to us, the part the expansion cannot tear away, is a rounding error against the whole, a single island against an ocean we can see and never cross. Everything beyond that island, the other 2 trillion galaxies, every cluster and filament and far structure in the deep images, is receding and will keep receding and will eventually be gone from our reach entirely. The universe we actually get to keep is not the glittering immensity in the telescope. It is one merged galaxy and its handful of bound neighbours, alone. The uncertainties here are small and worth stating plainly. Exactly which of the smaller galaxies stay bound, and the precise timing of the Milky Way and Andromeda merger, carry some uncertainty, the kind of thing that shifts a number by a bit, without changing the picture. But the basic division is firm and not in serious doubt. What is gravitationally bound stays. What is not bound recedes and is lost. And the line between those two fates runs very close around us, enclosing our own small group and almost nothing else. We do not get a galaxy supercluster. We get a neighbourhood. It is worth dwelling on how the local group survives when everything else is torn away, because it is the one piece of good news in this whole subject, and it is a narrow piece. Within a bound group of galaxies, gravity is stronger than the local effect of the expansion. The galaxies have in effect already collapsed out of the smooth outward flow and fallen into orbit around one another, held by their mutual pull. The expansion still happens in the universe at large, but inside a gravitationally bound island it does not pull the members apart, because gravity there has already won. So our local group is not racing outward with the rest. It is a small knot that pulled itself together early and will stay together, a raft that does not break up even as the sea around it widens beyond all crossing. But notice how small that raft is against the ocean it floats in. The bound group that survives is around 50 galaxies. The universe we can currently see holds something like 2 trillion, so what stays with us, what gravity saves from the expansion, is on the order of 1 part in 40 billion of what is out there. Everything else, the other essentially all of it, is not bound to us, is receding, and will keep receding until it is gone past reach and then past sight. The merged remnant of the Milky Way and Andromeda and their few dozen companions is the entire inheritance, the whole of the universe that the expansion will allow anything here to keep. And even calling it an island flatters the situation, because an island at least sits in a sea you can see across. This bound group will sit in a dark that grows not just wider, but emptier, as the rest of the universe recedes beyond the reach of light. The raft holds, but the ocean around it does not stay a visible ocean. It becomes a void, which is the final turn of this, the one that takes the prison past mere confinement and into something stranger, because the loss does not stop at reach, it comes for the view as well. It is worth picturing the night sky over that final merged galaxy, because it is where this is all heading, and it is not so far in spirit from our own. From a world inside that combined island of stars, there would be a band of stars across the sky, the merged disk seen from within, much as we see our own galaxy as a river of light overhead now. There would be the nearby stars of that island, rising and setting, and beyond all of it, in every direction, nothing. No other galaxies hanging in the dark, no faint far smudges, no sense of an immensity beyond the home island. The local sky would look rich, and the universe beyond it would be as far as anything there could tell, simply absent. That is the inheritance then, in full. Not the 2 trillion galaxies of the deep images, not the clusters and the filaments and the great structure of the visible universe. One merged galaxy, its bound companions, and a surrounding dark that holds nothing reachable, and in time, nothing visible. Gravity saves the island, and the expansion takes the sea, and the ratio between what is saved and what is taken is 1 part in tens of billions. We tend to think of ourselves as inhabitants of a universe. The truer description on the long view is that we are inhabitants of a single bound group of galaxies, briefly able to see a universe we are not part of and cannot join. It is worth saying plainly what holds the local group together while the rest flies off, because it is the hinge the whole fate turns on. Gravity and the expansion are in a quiet contest everywhere, and the winner depends only on whether things are close and massive enough for their mutual pull to beat the local stretching. Within a galaxy, gravity wins overwhelmingly, so galaxies do not expand. Within a bound group of galaxies like ours, gravity also wins, so the group stays knit together and will not be pulled apart. But out in the open gulfs between unbound groups, there is too little matter and too much space, and there the expansion wins, and wins by more every year. So the line between what we keep and what we lose is simply the line where gravity stopped being able to hold against the growth of space, and that line falls just outside our own small group. Think of the merged galaxy that remains as the only country there will ever be. Right now we speak of the universe as our context, the immense thing we belong to, and we think of ourselves as small inhabitants of something enormous. The long truth is narrower. The thing we belong to, the thing that stays with us against the expansion, is one group of around 50 galaxies that will fold into a single combined island of stars. That island, and nothing beyond it, is the whole of the reachable universe in the end. So the honest scale of our home is not the universe at all. It is a galaxy and its bound companions, a single lit island, with everything else either already unreachable or on its way to becoming so, and an emptying dark on every side. The one piece of durability in all of this is that the bound island, once formed, lasts an enormous time. The merged remnant of our galaxy and its companions will hold together long after the rest of the universe has receded from view, a stable knot of stars bound by its own gravity, outlasting the visibility of everything beyond it by an unimaginable margin. So the inheritance is not fleeting in itself. It is small, it is alone, and it is surrounded by a growing dark, but it endures. That is the shape of what remains then. Not a universe, not a network of galaxies, not an open field of destinations, but one durable island of stars, holding together by its own gravity, in an emptiness that widens forever around it, keeping its own light long after the rest has gone. And here is the part that goes one step past everything we have said, the step that makes this not just a prison, but a particular kind of cruelty. Losing the rest of the universe to unreachability is one thing. We could suppose a far future people, sealed in their bound island, still looking out at the receding galaxies, still able to see the immensity they could never touch, still knowing it was there. But that is not what happens. In the far future, the rest of the universe does not merely become unreachable, it becomes invisible. It goes out, not just out of reach, but out of sight. In about 100 billion years, the night sky over our merged galaxy will be empty of everything except that galaxy itself. Every other galaxy, all 2 trillion of them, will have crossed the cosmic horizon and had its light stretched so far by the expansion that it fades past any possibility of being detected. The other galaxies do not just become unreachable the way they already are, they become invisible. They redshift into the dark until there is no instrument, no matter how sensitive, that could ever catch a single photon from them. They simply go out. So consider what the universe looks like to whatever exists then. On some world in that merged island of stars, looking up, they see their own galaxy, a band of stars across the sky, and beyond it, in every direction, perfect black. No other galaxies, no faint smudges of light from far clusters, and no afterglow from the beginning either. Because the leftover radiation from the hot early universe, the cosmic microwave background that we can still detect today as the echo of the Big Bang, will itself have redshifted away into undetectable nothing. The sky will hold one island of stars and an infinite, featureless dark, and that is all. Now here is the truly strange part, the part that I find almost harder than the loss itself. An observer in that far future, studying that sky with every tool physics allows, would have no way to know that any of the rest ever existed. They would see one galaxy, static, with nothing receding from it, because everything that could recede has already gone. They would find no evidence of expansion, because the things whose motion reveals the expansion are gone from view. They would find no echo of a hot beginning, because that echo has faded past detection. From everything they could actually observe, they would conclude that the universe is one island of stars in an unchanging void, with no beginning and no expansion and nothing beyond. They would be completely wrong, and there would be no way for them to know it. That is the answer to the question I asked you to hold. Does the wall stop where it is, leaving us at least the view, or does it keep closing until it takes even that? It takes even that. The closing does not stop at unreachability. It runs all the way to invisibility, and past that to a kind of forgetting built into the universe itself, where the evidence of everything outside the wall is erased, not by anyone, but by the plain stretching of space carrying it all beyond the reach of light. The prison does not just hold us in. In the end, it convinces its inmates there was never anything outside. And I should be honest that this is a prediction about the deep future, extrapolated from the physics we have now, and the assumption that dark energy stays as it is. It is a robust result, one that falls straight out of the standard model of the universe, and the broad shape of it is not really in dispute among the people who study it. But 100 billion years is a long way to extend any theory, and the deep future always carries the quiet caveat that physics we do not yet understand could change the ending. What is not in doubt is the direction. Everything we can measure says the sky empties, the evidence fades, and the island is left alone. The detail that makes the empty sky more than a sad image is what it does to knowledge itself. Everything we understand about the universe, that it is expanding, that it began in a hot, dense state, that it is full of galaxies stretching out in every direction, we know because we can see those things. The expansion we read in the redshifts of distant galaxies, the hot beginning we read in the faint background glow that fills the sky, the cooled echo of the early universe. The contents we read in the deep images full of galaxies. Every one of those pieces of evidence is light arriving from far away, and every one of them fades, in the far future, past the point where any instrument could catch it. So a civilization arising in that far time, on a world in the merged remnant of our galaxy, would look out with the best instruments physics allows and find a sky that lies to them by omission. One galaxy, theirs, surrounded by black, no red-shifting galaxies to reveal an expansion, because the galaxies are gone from view. No background glow to reveal a beginning, because it has stretched past detection, they would have every reason to conclude that their island of stars is the whole of existence, static and without a beginning, sitting alone in an empty void. And nothing they could observe would correct them. The true history of the universe, expansion, beginning, the immensity of galaxies, would be not just unknown to them, but unknowable, erased from everything they could measure. That is the strangest cruelty in the whole picture, stranger than the unreachability, stranger than the shrinking. The universe does not only seal its inhabitants into a small bound island, in the end it removes the evidence that there was ever anything else, so that the prison comes to look, from the inside, like the entire world, with no walls visible because there is nothing left beyond them to see. We are fortunate, in a bleak way, to live early enough that the evidence is still here, that the sky is still full, that we can still read the expansion and the beginning in the light. That chance is open now. It does not stay open. The pieces of evidence that vanish are worth naming, because losing them is what turns the empty sky into the end of knowledge, rather than just the end of scenery. There are three great pillars on which our understanding of the universe's history rests, and all three are made of light from far away. The first is the recession of the galaxies, the redshifts that reveal the expansion, which disappears once the galaxies themselves are gone from view. The second is the faint background glow that fills the whole sky, the cooled light left over from the universe's hot, dense beginning, which redshifts further and further until no instrument can register it. The third is the particular mix of the lightest chemical elements, forged in the first minutes, which becomes impossible to read once the distant gas that carries the record is beyond sight. Strip away all three, and a future astronomer has nothing left to reconstruct the true history from. They would not be ignorant through any failure of intelligence or instruments. They would be ignorant because the evidence itself would have left the observable universe, carried beyond the horizon by the same expansion that took the galaxies. They would build, from what little remained, a perfectly reasonable and completely wrong picture, a single unchanging island of stars in a static void, the very picture humans held a little over a century ago before we learnt better. The difference is that we were able to correct it because the evidence was still here to be read. They would have no such chance. The universe will have closed the book and removed it from the shelf. There is a reason this scenario is sometimes called the end of cosmology, and it is precise rather than dramatic. Cosmology, the study of the universe as a whole, its history and structure and origin, is only possible because the evidence is reachable, because the light of distant galaxies and the glow of the beginning still arrive here to be read. Strip that evidence away, as the expansion eventually will, and the questions cosmology answers become permanently unanswerable. Not hard, but impossible, because the data needed to answer them will have left the observable universe for good. A thinking being in that far time could be as brilliant as any who ever lived and still could not discover that the universe expands or that it began, because every trace of those facts will be gone beyond the horizon. Knowledge itself has an expiration date out there, set by the same wall that seals away the galaxies. And the fact that we can still read the true history is itself a kind of fragile luck, worth naming before it slips by. We live in the early age, when the galaxies are still in the sky, when the redshifts still reveal the expansion, when the faint background glow of the beginning still arrives to be measured. Everything we know about where the universe came from depends on that evidence still being here, and it is here only because we arrived early enough. A thinking being 100 billion years from now would have none of it, and would build a false and tidy picture of an unchanging static island, never knowing how wrong they were. We are not in that position, not yet. We hold the full evidence of a universe that is, even now, in the slow process of carrying that evidence away. Reading it while we still can is one of the few things this situation actually offers. There is something almost vertiginous in imagining a thinking being in that far time doing careful, honest science and arriving at a confident, complete, and entirely false picture of the universe. They would measure their single island of stars, find it stable and bound, see nothing receding because nothing is left to recede, detect no glow from any beginning because it has faded past all instruments, and conclude, with every reason and no error they could detect, that the universe is one unchanging island in a static void. Their physics would be self-consistent. Their observations would be impeccable, and they would be wrong about the most basic facts of their own universe, its expansion, its origin, its former immensity, with no possible way to discover the error because the evidence will have left their reach forever. That is the final shape of the closing, and it is why being early is the one genuine gift in this whole bleak picture. We can still see the galaxies. We can still read the expansion in their light and the beginning in the background glow. The evidence is still here, still arriving, still legible, and it will not always be. So we are among the observers who get to know the truth about the universe, not because we are wiser than those far future beings, but because we happened to arrive while the universe still showed its hand. The closing has not yet hidden the cards. It is hiding them, slowly, and we are reading them in the last long age when they can still be read. There is a bitter symmetry I cannot get past in this. We have, in this brief early age, just barely figured out the true story of the universe, that it expands, that it began, that it is filled with 2 trillion galaxies streaming apart, and we figured it out by reading the light of distant things. And the very expansion we discovered is the thing that will in time carry all that light away and erase the evidence, so that the truth we just learnt becomes permanently unlearnable. We arrived in time to read the story, and also in time to understand that the story is being deleted, that the time for knowing it is open now and closing, that the universe is in the slow act of forgetting its own origin and taking the proof with it. To know all that, and to know we are early enough to still see it, is the strangest place this whole subject leaves me. And that far future island will not be dead or lifeless, which is part of what makes the blindness so complete. The merged remnant of our galaxy will go on forming stars for a long age, holding worlds, perhaps holding life and minds as capable as any. The tragedy is not that there is no one there to look. It is that there could be someone there to look, thinking and curious and equipped with every tool, gazing out at a sky that tells them nothing of the truth, a sky swept clean of every other galaxy and every trace of the beginning. They would have the capacity to understand the universe and none of the evidence, a mind in full working order, pointed at a void that has hidden its own history. We are the opposite case, minds with the evidence still in front of us, and the only difference between us and them is when we happen to live. So the closing is complete eventually. Not just most of the universe out of reach, but in the end all of it out of sight, and even the memory of it gone. Which leaves the question that has been sitting underneath this whole thing, the one we have been circling. If this is the situation, if the walls are this total, then is there really no way out? We are a clever species. We have broken through limits before. So why is this different? Why does no amount of cleverness get us out of this one? Because these walls are not made of difficulty. They are made of physics. Every limit we have walked through tonight is fundamental, woven into the structure of space and time, not a practical obstacle waiting for a better machine. That is the difference that matters, and it is the difference between every barrier humans have ever broken and this one. We have broken hard barriers before. We have not, and on everything we know cannot, break the laws that set these. Take them one at a time. The speed of light is not an engineering ceiling that a cleverer engine clears. It is built into how space and time are related, so deeply that to exceed it you would have to unmake cause and effect. The expansion is not a wind we could shelter from. It is a property of space itself, happening everywhere, including in the space inside any ship we built. And the cosmic event horizon is a boundary that recedes faster than light, which means no permitted speed, not the speed of light itself, ever catches what lies beyond it. You cannot out-engineer a finish line that moves away faster than the fastest thing the universe allows. There is no craft, no drive, no trick of acceleration that reaches it, because reaching it would require beating light, and beating light is not on the table. The escapes people reach for all run into this same wall. Faster than light travel breaks the speed limit directly, and there is no evidence it is possible. Wormholes, shortcuts folded through space, appear in the mathematics only under conditions, like exotic matter with negative energy, that we have never found and may not exist, and even on paper they collapse the moment you try to make them usable. Warp drives that move space around a ship, rather than the ship through space, turn out to demand quantities of impossible energy, and raise paradoxes the universe seems built to forbid. None of these has any experimental support. Not one has ever been shown to be anything more than equations describing something reality may simply not permit. To stake an escape on them is not a plan, it is a wish wearing the clothes of a plan, and the universe has not agreed to it. I want to be careful and fair here, because there is a real humility the science demands. Physics is not finished. We do not understand dark energy. We have not joined gravity and the quantum world into one theory. It would be arrogant to stand here and declare that no discovery in all the ages to come could ever change anything about this. So I will not say that. But there is a difference between holding the door open out of honest humility and pretending we can already see a way through it. Right now, on everything we actually know, there is no way through. The walls hold. The part of the universe already on their far side is lost for good, and nothing in the laws as we understand them offers a way to follow it. It is worth taking the escapes seriously enough to see exactly where each one fails, because they are not all foolish, and people who raise them are often not foolish either. Faster than light travel is the simplest wish, and it fails at the root because exceeding light speed in the framework that governs space and time does not just require more energy, it tangles cause and effect, allowing effects before their causes, which the universe shows no sign of permitting. A wormhole, a tunnel joining two distant points through a fold in space, is a real solution in the mathematics of gravity, but the versions that could actually carry anything require a kind of matter with negative energy that has never been found in the amounts needed and may not exist at all, and even then they tend to pinch shut the instant anything tries to pass. The warp drive, a bubble that moves space around a ship rather than moving the ship through space, is the most sophisticated of the dreams, and it too dissolves on contact with the numbers. The energies it would demand are beyond anything imaginable, in some versions exceeding the energy of entire stars, and many forms again require that same exotic negative energy we have no evidence for. None of these ideas is supported by a single experiment. None has ever been demonstrated to be more than equations that might describe something the universe quietly forbids. They are not technologies we have not built yet, the way a faster rocket is a technology we have not built yet. They are possibilities the laws of physics, as best we understand them, appear to rule out. And the deepest reason none of them helps with this particular prison is the cosmic horizon itself. Even granting, for the sake of argument, a ship that could somehow travel at the very speed of light, it still could not reach what lies beyond the horizon, because that boundary recedes faster than light, carried out by the expansion. You cannot catch a finish line that retreats faster than the fastest thing the universe allows, no matter how perfectly you run. So even the impossible dream of light speed travel, fully granted, does not open the prison. The far galaxies are not merely hard to reach. They are behind a line that outruns light, and nothing the laws permit outruns light. That is why this is not a frontier. A frontier can be crossed. This cannot. There is a temptation, hearing all this, to lean on the fact that physics is unfinished, and hope that some future revolution simply dissolves the walls. And I understand the pull of it, but it is worth seeing why it is thinner than it sounds. Yes, we do not have a complete theory. Yes, dark energy is a mystery, and gravity and the quantum world are not yet joined. But the walls we have described do not hang on the unsolved parts. They hang on the best established physics we have, relativity and the observed expansion. Tested to extraordinary precision across a century, a future theory will have to contain everything those theories already get right, the way a deeper map still has to show the rivers the old map showed. It could add new things at the edges. It is not likely to overturn the speed of light or the expansion themselves, because those are not loose ends. They are among the most firmly nailed down facts we have. So the honest stance is a narrow kind of humility, not a wide one. It would be arrogant to say that nothing we ever learn could change any part of this. It would be just as dishonest to suggest that the way out is probably there, and we simply have not found it yet. There is a difference between admitting we cannot see the whole of physics and pretending we can see a door where the laws show a wall. On everything actually known, the walls hold, the horizon outruns light, and the lost part of the universe stays lost. Hope that ignores that is not hope. It is the refusal to look at the thing the whole video has been about. And the horizon is the part that defeats even the most generous imaginable technology, so it is worth stating once more in the plainest way. Grant a ship that flies at the very speed of light, the absolute ceiling, something already impossible for anything with mass. Even that ship cannot reach a galaxy beyond the cosmic event horizon, because the distance to that galaxy is growing faster than light, so the ship, moving at light speed, still loses ground against it forever. The finish line is not merely far, it is retreating faster than the fastest possible runner can run. No conceivable improvement in propulsion changes that, because the problem is not the speed of the ship, but the growth of the space, and the growth already beats the only speed the universe allows. This is why the lost galaxies are lost in the strict sense, not hard to reach, but provably impossible to reach, by anything, ever. It is fair to ask whether some completely unforeseen physics could change everything, and the honest answer respects both the possibility and its limits. We genuinely do not have the final theory. There may be deep things about space and gravity and dark energy we have not grasped, but the limits in this video do not rest on the unknown parts. They rest on relativity and the measured expansion, two of the most heavily tested pillars in all of science, confirmed in countless independent ways. A future theory will have to keep everything those already explain, the way any better map still has to agree with the coastline the old one drew. It might add new country at the edges of our knowledge. It is not likely to repeal the speed of light or undo the expansion, because those are not the loose threads, they are the fabric. So the door stays open only to the genuinely unknown, not to the wishful, and the wall, as far as anything we actually know reaches, holds completely. It helps to be clear about why this barrier is a different kind of thing from the ones we have broken before, because our whole confidence as a species comes from breaking barriers. We were told we would never fly, and we fly. We were told the sound barrier was a wall, and we passed it. We split the atom, reached the moon, decoded the molecule of life. Every one of those was a barrier of difficulty, a hard engineering problem that yielded to enough cleverness and effort. The walls in this video are not that. They are not problems of difficulty. They are features of the geometry of space and time, the speed limit woven into causality, the expansion built into space, the horizon that recedes faster than light. There is no amount of cleverness that edits the geometry of the universe, because cleverness operates inside that geometry, not above it. So this is not a not yet the way flight was a not yet before the first aircraft. A not yet is a barrier we have not got to. This is a barrier the laws themselves forbid crossing, the difference between a lock we have not picked and a door painted on a solid wall. Even a civilization far beyond us, with energy and knowledge we cannot dream of, would face the same horizon receding faster than light and the same speed limit on everything they could send, and they would be just as sealed in their own bound island as we are in ours. The confinement does not scale away with advancement. It is not waiting for a smarter species. It is the shape of the universe, The same for anyone, anywhere, at any level of genius, and that is precisely why it is a prison and not a frontier. It is worth being clear that this is not at bottom an energy problem, because that is the form the last hope usually takes. The idea that with enough power anything is reachable. Harness a star, harness a black hole, command the output of an entire galaxy, and it changes nothing about the horizon, because energy only ever buys speed, and speed is capped at light, and light is not enough. The galaxies beyond the line recede faster than light, so no quantity of energy poured into going faster crosses the gap, since there is no faster to be had past the speed of light, no matter how much power you hold. This is what makes the wall final in a way no barrier of difficulty ever is. A difficulty barrier yields to more power, more cleverness, more time. This one does not, because the thing you would need more of is forbidden to exist. You cannot buy your way past light, and past light is the only thing that would help. So the honest position is the hard one. This is not a frontier that is difficult to cross. It is a boundary that cannot be crossed, made of the same physics that lets the universe exist at all. The reachable universe is small, it is shrinking, and the walls around it are not the kind of thing cleverness defeats. Which leaves only the last question, the one that is not about physics at all, but about what all of this means, once you stop calling the universe a frontier and start seeing it for what it actually is. The universe is not an open frontier we are beginning to explore. It is a closing cell. Pull everything from tonight into one place and that is what is left. The distances alone are nearly impassable, tens of thousands of years to the nearest star, at our best speed. The speed of light caps every crossing at a ceiling we cannot raise. The expansion of space widens every gap, faster all the time. Beyond the Hubble radius, the gaps open faster than light itself. Most of the 2 trillion galaxies we can see are already past the horizon we could ever reach. The small reachable fraction is shrinking every year. In the end, only our own merged neighborhood remains, and in the far future even the sight of everything else is gone, along with the evidence it was ever there. And notice where the fear actually lives, because it is not where the frontier story puts it. The frontier story says the frightening thing about space is the loneliness of the crossing, the cold and the distance and the long dark between the stars, as though the tragedy is how hard it will be to get out there. That was never the real weight. The real weight is that there is almost nothing out there we are allowed to cross to. The crossing is not the problem. The destination is forbidden. The universe is not a hard road to somewhere. It is a cage whose walls are made of physics, with almost everything we can see already on the far side of them. And we happen to be living in the brief age when the bars are still lit by the light of everything we will never reach. Pull the whole shape of it together one last time before I say what I think it means. We began with distance, and found that our fastest machine in 50 years has crossed one light day, with the nearest star tens of thousands of years away. We found that the speed of light caps every crossing and turns the far universe into a record of the past we can never answer. We found that space itself is expanding, faster all the time, so the gaps widen as we watch. We found that beyond a certain line the gaps widen faster than light, sealing off whatever lies past them. We found that this has already happened to the great majority of the 2 trillion galaxies we can see, that the reachable part is a small minority and shrinking every year, that in the end only our own bound neighborhood remains, and that in the far future even the sight of everything else is gone, along with the evidence it ever was. Every one of those is true at once, about the same universe, the one we live in and call open. And none of it is an argument against looking, against wonder, against sending what we can as far as we can. It is an argument against one specific comfort, the idea that the universe is a frontier waiting for us, an open country we are about to spread into. That idea is not true, and the truth in its place is harder, and I think more worth knowing. We are not at the threshold of the universe. We are deep inside a small and closing part of it, in the brief age when the rest is still visible, holding a view of an immensity that was never ours and is quietly leaving. I think the thing that stays with me most is the timing of our own moment. The fact that we are early, we happen to be alive in the age when the universe is still full to look at, when the galaxies are still there in the deep images, when the light of the far reaches is still arriving, and the evidence of the expansion and the beginning is still readable in the sky. That opening is not permanent. It is on the cosmic clock, a relatively brief early age, before the expansion carries it all out of reach and then out of sight. Whatever comes long after us inherits a smaller, darker, more deceiving universe than the one we get to see. So there is a strange privilege folded into the bleakness, and I do not want to oversell it into comfort, because it is not comfort. It is just true. We are among the observers who can still see how much there is, even as we learn that almost none of it was ever ours. We are holding a full view of a closing universe, able to read the whole story precisely because we arrived before the evidence left. That is the position we are in, and it is not the position the frontier story describes. We are not at a beginning, looking out at everything we are about to claim. We are partway through, looking out at almost everything we have already lost, in the last age when it can still be seen. What I find the argument actually does, once I sit with it, is turn my attention around, away from the immensity, and back toward the small bound thing we are part of. If almost nothing out there was ever reachable, and the reachable part is shrinking, and only our own group of galaxies will ever be ours, then the thing that matters is not the unreachable immensity, but the island we actually have, this galaxy, this group, this world. The frontier story points us outward, toward an everything we are told is waiting. The physics points us back inward, toward the little that is genuinely ours, the only ground there will ever be. That is not a comforting redirection exactly, but it is an honest one, and it is the opposite of where the dream of an open universe was sending us. And I keep landing on the same quiet correction to the story we are usually told. We are raised on the idea of space as the great outward adventure, the frontier our descendants will spread across, and that idea has a pull, I feel, as much as anyone. But it is not what the physics describes. The physics describes a small bound island in a universe that is mostly already beyond us, and getting more so. A view of an immensity that was never ours, lit for a while by the light of places we cannot go. That is a harder thing to hold than the adventure, and I think it is also the truer thing. And the truer thing is what this channel is for. Not the open frontier, the closing one, seen clearly, while there is still light enough to see it by. What I take from it, in the end, is not despair, though I understand reaching for that, and it is not the false comfort of pretending a way out exists. It is something quieter, a kind of corrected attention. If the immensity was never ours, and the reachable universe is small and shrinking, then the things that actually matter are the near ones, the ones genuinely within our small bound island, this galaxy, this group, this single living world. The frontier story spends our wonder on an everything we can never have. The truth spends it on the little that is real and present and ours, which turns out to be rare beyond any reckoning, a lit island in a dark that is only growing. We are not going to escape into the universe. So the question the physics leaves us with is not how to get out. It is what we make of the one small place we were given in the brief age when we can still see by the light of all the rest. Whether you take that as cause for despair or as a reason to hold tighter to what is near is not something the science can decide for you, and I am not going to pretend it can. The facts do not tell you how to feel. They tell you only the one thing that is true no matter how you feel about it, which is that the reachable universe is small and shrinking and walled, and that almost everything we can see was never ours and is leaving. So before I let you go, let me tell you what all of this has come to mean to me, standing at the end of it, having looked at the size of the prison as honestly as I know how. Here is what I keep coming back to. When you look at a galaxy far enough away, you are not seeing it. You are seeing light it gave off billions of years ago, and the galaxy itself has been carried so far by the expansion of space that you could never reach it, never signal it, no matter how fast you went. You are looking at a ghost, and most of the universe is now made of those ghosts. Light still arriving from places already gone beyond the wall. Almost everything we can see already lost for good. That is the part one find hard. Not that the universe is big. We have always known it was big. It is that the size is not an invitation. It is a sentence. The space between us and nearly everything is growing faster than anything can cross. So the door was shut before we were born, and it is still shutting, galaxy by galaxy, every year. In the far future, the sky will empty completely, and whatever is alive then will look up and see one island of stars in an endless dark, with no way of knowing the rest was ever there. We live early enough to still see it all, the other galaxies, the light of how much there is. But seeing is not reaching. We can watch almost all of it, and we can keep almost none of it. We were never standing at the edge of the universe, about to walk out into it. We were always inside, one small bright island of light, with the dark widening around us and carrying off everything but the little we were given. This is the only ground there is, and we are not leaving it. If you stayed all the way out here in the dark with me, a like or a subscribe helps the next one reach someone who would have wanted to come along. Sleep well.